The distinction between old science and modern science is rooted in both the methodologies used and the understanding of the natural world. Although both share a commitment to exploring and explaining the universe, the approach and tools available to scientists have evolved dramatically over time. Old science primarily refers to scientific practices from ancient civilizations through the early Renaissance, where observation, philosophy, and religious or mythological beliefs played significant roles in shaping explanations of the natural world. Ancient scientists such as Aristotle, Pythagoras, and Hippocrates used simple tools, observations, and reasoning to explain phenomena. For example, in ancient Greece, scientists believed in the concept of four elements: earth, air, fire, and water, as the fundamental components of all matter. These theories were largely qualitative, based on direct observation, but lacked the advanced experimental tools to test hypotheses rigorously. In old science, knowledge was often confined to the elite, such as philosophers and priests. Theories were often not subject to the kind of scrutiny or experimental testing that we expect today. Many explanations were intertwined with religion or superstition, with events attributed to the will of gods or divine intervention rather than natural causes. Moreover, there was a significant reliance on deductive reasoning rather than inductive methods. As a result, the scope of scientific exploration was limited, and many conclusions were based more on speculation than empirical evidence. Modern science which emerged during the scientific revolution in the 16th and 17th centuries, marks a turning point where rigorous testing, experimentation, and the scientific method began to dominate. Figures like Galileo, Newton, and Copernicus introduced observational methods that made it possible to test theories against real-world evidence. For example, Newton's laws of motion and gravity were formulated through observation, experimentation, and mathematical modeling, creating a more predictable and mechanistic understanding of the universe. Modern science emphasizes empirical data and quantitative analysis. It relies heavily on experimental controls, reproducibility, and peer review to validate findings. The technological advances of modern times, such as the microscope, telescope, and later, computer models, have expanded the ability to observe and understand phenomena that were previously invisible or unknowable. Fields like quantum mechanics and molecular biology have unveiled insights that were inconceivable in earlier periods. Furthermore, modern science is interdisciplinary, with collaboration between different branches such as physics, chemistry, biology, and computer science. It recognizes the importance of falsifiability, meaning that for a theory to be scientific, it must be testable and potentially disprovable. This methodological approach fosters a deeper and more accurate understanding of the world, moving beyond ancient assumptions and superstitions. In summary, the major difference between old and modern science lies in the shift from speculative and religiously influenced explanations to data-driven, experimental approaches. Modern science's ability to test, refine, and challenge ideas has vastly expanded human understanding of the universe.